Welcome back to class 14. I have way too many examples, but here's some more. Example 5-6 out of Cengel. We're compressing air in a compressor. We just did a problem like that. Anyway, we're going to do it again. So we have 100 kilopascals and 200 degrees Kelvin. That's the air as it's coming in, right over here. I lost it. There you go, right there. And it's compressed steadily to 600 kilopascals at 400 degrees Kelvin. The mass flow rate is 0.02 kilograms per second, and the heat loss, all right, so maybe it's just not insulated very well, so heat's just flowing right out of that thing. It occurs during the process. Assuming the changes in kinetic energy and potential energies are negligible, we don't have to do that. Determine the necessary power input to the compressor. So that sounds like a pretty standard kind of problem. Something you'd want to know how to do. All right, so we got air. We got a flow going on. So the do we have flow? We do have flow. So the main equation for us is Q dot minus W dot, so heat flow minus the power, plus the summation of the mass flow times the total enthalpy inlet minus the summation of all the mass flows times the summation or the enthalpy, the total enthalpy exiting. And this total enthalpy will include both the thermodynamic enthalpy and also the kinetic energy enthalpy. But we have been saying we're going to get rid of them right there, right? So we could just say HI. We don't have NHE. We didn't have to do total right there. And there's going to be the same mass flow multiplied by all of these. So this is equivalent to saying this right here. Right, so that could be between 1 and 2, and this could be 1 and 2 right here. And this is going to be work in, but let's keep it as negative right here. This is going to be negative right here, right? That's 16 kilojoules outwards. So let's go ahead and go negative 16 minus W. We expect the answer to be negative at the end, plus H1. Well, let's see. Let's take a little detour over here and go to table A.7.1 and look at T equals, and we said 280 in, and that's 1, and T2 was 400. All right, so we'll say that the air is only dependent on the temperature, or its enthalpy is, and let's look him up. Go to A1. Oh, what did I say? I think it's A7. A7? Here, A7. Boom. So we said the inlet is 280. So this guy. So we want so close to being 280 itself. H1 is 280.39 kilojoules per kilogram. Must be a symbol for that. Make it life easier. Here's 400. We got just a little bit more, 401. So H2 is 401.3 kilojoules per kilogram. And we can come back and put those in place. H1 is 280.39 minus H2, which is 401.3. What we get is, well, that's supposed to be a lower W. I'm going to try to make it look like a lowercase w. From 1 to 2. Better be a negative number because we anticipate it being a negative number because its work is in. We just didn't put the negative with the negative in there. We had 136.9 kilojoules per kilogram. And they told us what the mass was, so we can find out what that's going to be. So here's the input right here. So the m dot times W. I guess I'll keep going to the 1 to 2 thing, but whatever. And so that was 0.02, right? Kilograms per second times 136.9, and so the power, is going to be 2.738 kilowatts. I also write, if you wanted to, we know that CP is 1.004 kilojoules per kilogram degree Kelvin, so that we could have said that this whole thing was going to be m dot times C sub P T2 minus T1 plus Q loss, right? Could have found the same values just from doing this right here. It's just this one equation. But there's way too many equations to memorize that are kind of like this, and to keep them track of each other. So it's kind of better to like just be thinking your way through the scenarios as a means, and also double check that the whatever equation that you're looking at is appropriate for the situation that you're dealing with. Because there could be too many equations to measure. And I can't stand when students said, I didn't know what equation to use. Well, if you go about the mentality of just trying to find one equation to solve a particular problem, it's going to be way too many equations to try to find, and I don't know what equation to use. It's going to be your excuse all the time. So don't do that. Don't think of it in that way. Try to think your way through the problem. Anyway, I don't need to write any more of this. This video got short. Short video is good. More short videos.